It's time to talk about money. All right, so we're going to talk about compound interest. If something if we get interest every year or something, the formula is relatively straightforward. But if the interest, like let's say we get 3% interest, but it's divided across the year, maybe it's compounded every quarter of a year, then the formula is a little bit more complicated, and that's what we're going to talk about right here. Okay? So, here's a little formula for you. A of t is equal to P times 1 plus R over N to the NT. Now, there's a lot going on here, okay? First off, I want to just bring your attention to that this is basically Y equals A times B to the X. This is our B. This is our growth rate. We'll talk more about what this is later. P is our starting amount. We'll talk more about that. And this is just our function. This is our output. You can leave that up or you can erase it. I'm going to talk about each of these. So this is the amount in an account after T years. Okay, it's a function notation, f of x, a of t. T is our independent variable. A is our dependent variable. It's also the name of the function. P stands for principal. And oh no, did I write it down? I didn't write it down. It's I don't know how to spell it. P is your starting investment. Okay? Otherwise known as a principal. All right. And then what's this other stuff going on here? R, that's your interest rate. Be very careful. A lot of times we say these as percents. 3% interest, 6% interest. Write it as a decimal. So 3%, write 0.03. And last but not least, N is the number of times it compounds in a year. That's not how you spell compound. So if it compounds annually, that's once a year. N would equal 1. Compounds quarterly, that's 4 times in a year. N would equal 4. And then T as before, right? T is the number of years. All right, so that's basically this formula. This is how we can calculate interest. So let's use it. Example 4. If Janet invests $2,000, that's her principal, at an interest rate of 2.75% per year. Not great. It's like very similar to inflation, depending on the year. And compounded quarterly. Question is, part A, how much will she have after 10 years? This is very similar to the question, how much is 2,000 could it be worth in 10 years? Because of inflation. That's the more depressing way of viewing this question. I don't know. Inflation makes me sad. But if I were more of an economist, then I don't think it should necessarily. I don't know. It's an interesting question. But I'm not an economist. I'm a mathematician. So let's just do the problem. Let's identify what we have here. A of t, that's what we're curious about. We're curious about the amount after t years, and specifically, t is 10. Okay? So it's equal to P. What is our P? P is our principal, our initial investment, $2,000, times 1 plus R. R is our interest rate. It's not quite 2.75. Interest rate here is going to be 0.0275, right? 2.75%. Watch out for that. Convert it to a decimal. So 0.0275 divided by n. N is the number of times it compounds in a year. It compounds quarterly. Every quarter of a year, that means 4 times per year. All right. So this is our formula. Just like so. Now you can simplify this formula, or you can directly type this into Desmos. All right. What is that going to look like? It's going to look like 2,000 times 1 plus R, which is 0.0275 divided by n. Press tab to get out of the denominator. Finish your fraction. Exponent. Parentheses and exponents are a good idea. N times t, like so. $2,630.58. 26.30.58. That's what I said, right? 26.30.58. Round to the nearest cent when we're talking about dollars and cents. So there we go. That's how much she'll have in this account after 10 years of this interest rate. Okay. Part B. Let's say if things compounded monthly. If it compounded monthly instead. That's not how you spell instead. Compounded monthly instead, how much more money would she make? So why does it matter how often it's compounded? It's still 2.5% every year. But if it's compounded all at once, that means you only get 2.5% of the original investment. But if it's compounded twice, like one and like here, right? The difference between 2% once a year and 1% twice a year. 2% once, you only get the 2% on the principal. 1% twice, you get 1% on the principal, and then another 1% on the result. So you get a 1% on the interest you've already acquired as well. That's why the more frequently it compounds, the better it's going to be for you. So let's just compare. So the only difference is, this is almost the same formula. The only difference is that now n is equal to 12. It's every month, so that's 12 times in a year. Again, we'll look at A of t. That's still 2,000. 1 plus r over n. Now n is different to the nt. Using this almost the same exact formula, and we'll type it into Desmos. Again, this formula is almost the same, but this is now 12 instead of 4, and this is now 12 instead of 4. 26, 32, 23. And the question is not how much will she have, how much more money is this? Well, our answer from part A was 26.30.58. Okay, so it's not that different. And this is supposed to be an 8. All right, it doesn't help her that much, compounding quarterly as opposed to monthly. But she gets like an extra $2. Let's subtract these. All right, if we subtract these, what are we going to get? We're going to get $1 and 65 cents, maybe? I think so. You let me know if my math is wrong. $1.65 more after 10 years. So she probably shouldn't lose any sleep about whether it gets compounded quarterly or monthly. It's probably not going to matter. Who knows? Maybe in 10 years, she'll really need that $1.65. All right. Last problem of this video. Example 5. So let's use this formula again. A of t is equal to P, which stands for principal, that I totally know how to spell, times 1 plus R over N to the NT. I'm guessing PLE. That's my guess. I'll check after this video. I'm guessing PLE is how you spell it. So using this thing, solve for R. Ooh, that's a lot of work. We're going to do it in steps. So first off, we have a number times a mess. We have to divide by that number. We're going to divide P on both sides. Okay, divide by P, divide by P. The left-hand side just becomes A. It's still A of t, but we're not having it as a function anymore, so let's just write it as A. A over P. The P's cancel on the right-hand side. 1 plus R over N to the NT. This is where things get a little tricky. We need to unlock this inside. We need to undo the outside. If I had something like x squared equals 4, what would I do? Because that's what we have here, right? We have an exponent. How do we undo this exponent? We took the square root of both sides. And for x squared, it would be plus or minus, but we're not worried about negatives here. Well, if I had x cubed equals 4, how would we solve that? We'd take the cubed root of both sides. Well, our exponent here now is nt. So we're going to take the root of both sides, just like we did in these other examples, but now it'll be the ntth root. You can also think about this as a fractional exponent. Fractional exponent. I think it's easiest here to think of it as a fractional exponent as well. You can also use a radical. So we get A over P to the 1 over NT, taking the ntth root of both sides, just like we're doing here. And that's going to cancel on the right-hand side. So we're trying to get, for R, we'll just subtract 1 now. Can't combine like terms on the left, so it'll just be A over P to the 1 over NT minus 1 equals R over N. And now multiply both sides by N. That's going to give us our answer that our interest rate is equal to N times A over P to the 1 over NT minus 1. So this is pretty complicated algebra, and unless you're really going like pretty deep into mathematics, it's not super important that you're able to solve this. But know that this is a formula you can also use for the interest rate. It may come up in the homework, and you don't have to rederive it. You can just use this formula here. Okay? But really what I care about next is, can you use this formula? Part B. Calculate the interest rate needed for an account of $9,000 to be worth $13,373.53 after 10 years of semi-annual interest. We're going to use the formula. Okay. Semi-annual interest, that means n's going to be 2. It's happening twice a year. Our principal, I'm trying to color code these. That was blue. $9,000. Our amount, A, that we want after 10 years is $13,000. I think that's pretty much everything. So R is going to be N times A over P raised to the 1 over NT power minus 1. And again, it's pretty messy, but you can type it into a calculator, just like so. Desmos is really useful for this, okay? Because you can just type it in almost exactly like you see. You have 2 times. Can you use brackets here in Desmos? No. So Desmos doesn't like brackets. Use parentheses. 2 times. Now we need a second parenthesis. 13. 373.53 divided by our principal raised the 1 divided by n times t. Again, parentheses are really good for exponents. Tab out to get out of the exponent. Minus 1. That's our interest rate. It's almost exactly 0.04. %. We need a 4% interest rate to get this kind of growth. That's just how you use this formula. And again, the big thing is just typing it in carefully into a calculator. Desmos is really useful for this. If you want to use your own handheld calculator, that's fine. Google even works too. I use Google Calculator all the time. It's my preferred, easiest way. Yeah, and that's pretty much it. I said that was the last problem, but I do just want to make a quick comment for those of you who this may benefit. Talking about n's, some wording notes. If n is 1, that means it's compounding once a year, annually. If n is 2, that's twice a year, semi-annually. N equals 3, that doesn't really happen. N equals 4, that's quarterly. N equals 12. You could also do like n equals 6 bi-monthly. I hate the word bi-monthly though, because sometimes it means twice a month and sometimes it means every other month. This would be monthly. 365 would be daily. Unless we worry about leap years. And then we can keep on going, right? Anyway, so this is a little cheat sheet for if you're working through things and you see a word and you say, what does that correlate to for n? Good luck on this compound interest, and let me know if you have questions.